primary
This
objects that
conference will
store
now be
data.
recorded.
Okay, the primary object that store the data is always a database table, right? So let's speak about the tables first. So in general, you don't create a table, guys, because so tables are created in the operations part actually. So they are created in ECC. Okay, the finance tables, sales tables, which will store the data, are always created in the transaction platform, not in the analytics platform. So actually, I told you, right, we extract the data using SLT or BODS. So how we extract is it's a table extraction. Suppose I have a sales table in ECC which has got some data. So how do you replicate the data into HANA? We get the table along with the data into HANA. So actually the data replication into SAP HANA is always a table replication. Okay, simple I can say database contains table. The major objects which will store the data is always tables contain, I can say rows and columns, I can say columns data. Okay, so now as we're speaking about tables, so data replication to SAP HANA is always a table replication. Okay, BW data replication is different, guys. We load the data into the data source. It's a data source based replication. So data replication into BI is through data source. From file or from ECC, we get the data into the data source. That's an extractor based replication, or I can say data source based replication. But whereas data replication or data loading into HANA is a table based. Okay. So you all know, so generally when you take ECC contains some database tables, finance tables, sales tables, HR tables, where the data will be stored. So loading data into HANA is just a table replication. You get the sales table directly into HANA along with the data. So that's the way we replicate the data into the tables. But as of now, in general, we never create a table. So it's very rare scenario you guys creating a table in HANA. So that doesn't happen much. Maybe sometimes testing purpose we create. But I just need to discuss some topics of the database tables. So this delta merge, okay, how this delta store and main store locations work. So to show that aspects, let's start creating a table. So yesterday we in the catalog folder, so we created a schema. It is Hana 52. Yes, this is the schema we created. So maybe if you want to work with your schema, right click on your catalog folder, you can filter out your schemas straight away. Go to your filters. So type Hana 52. Say okay. Then that will display only your schema. So if your schemas are huge, okay, so if you have more number of schemas, you can search with your schema name. Simple. So go to your catalog folder, right click in the filters, give it. Sorry if you remove now. So now you see all the schemas. Right click on your catalog folder, go to the filters, search for HANA 52. So, okay, there you see the schema. If you open the schema, so there you see a tables folder. So this folder is completely empty. Now you can start adding the tables into this folder. Okay, so you can start creating the tables into the folder. So this table creation can be done in two ways, maybe using UI, user interface, and SQL script. I'll show you both. Okay, so right click on your tables folder, so pick the option. So there is an option called let's create a new table. So name of the table, I'm giving it as something like customer table. So this table will be created under HANA 52 schema. And type of the table is you have a choice when you're creating a table in HANA. So we always have a choice to choose between row store or a column store table. Okay, so here I'm choosing it as a column store table. By default, we always go with columns. So what is a table type? I'll discuss. When I'm creating some procedures, I'll discuss about the table types. I'm creating a column store table. So I'm just giving some columns. So first column is customer ID. So data type, integer data type. I'm going with integer data type. So then second column, I'm going with customer name, CNAME, customer name. So the data type is varchar with maximum length as 15. Means maximum data length is 15. Varchar means it allows all alphabets, numbers, and special symbols. I'm going with customer address. This is something like varchar 20. I'm creating another column, customer phone number. This is integer data type. If it is integer data type, no need to mention the length, it will automatically pick the length. Okay, so I'm just creating a very basic table, a customer table. Okay, so given the name, choosing the type of table as column store table, the schema is Hana 52. So and this table is getting created with 4 columns: customer ID, customer name, address, and phone number. So now here there is an option. Let's say execute your table. Let's execute your customer table. Okay. So now once you click on execute, your table is created. So if you go to your folder, tables folder, right click, please refresh once. Sometimes if you create any object, you don't see the object immediately, just make a refresh. So they can see the customer table has been created successfully. So there on the tables folder, you can see your customer table. So that was created successfully here. So if you go to the next tab, indexes tab, indexes I'll discuss. Okay. So now, okay, this is your table. If you want to close the table, simply close it. So now your table is created. If you want to open the table again, so right click on the table. Let's pick the option open definition of the table, or you can double click, both will work. If you go to the open definition of the table, you can see all the details here. So indexes and further properties I'll discuss later stage. If you go to the runtime information of your table now. So as the table created is a column store table, there you can see the memory consumption in delta storage and main storage. So I told you, right, any column store table we create, it will be created with 2 storage locations, delta and main storage location. So right now there is no data in the delta and main storage location, so that's why it's blank completely. And number of entries in the table is 0 completely. Okay, now let's write some data into the table so that I can show you how this delta and main storage locations work, how the merging happens. So to write the data into the table, so go to your SQL console. So generally always keep it in very in real time. We never create a table or never write the data into the table, because data written should be always from the business. So whenever the transactions happen, then only data will be created, guys. So in general, we never write the data manually, please. So I'm writing data into this customer table. So how do I write the data? I say insert into table. You can give manually, or you can simply drag and drop your table here. Insert into this table Hana 52 schema dot customer table. So you always see schema name dot table name, guys. Because you can have the same table. You can have a customer table in multiple schemas. You can have single table. You can have multiple tables with same name under different schemas. Okay. Okay. Under different schemas, we can have single multiple tables with same names. But in one schema, you cannot have two tables with same name, customer table. So that's why schema name dot table name is always a unique stuff. And in HANA 52 schema, you cannot have another customer table. Maybe in HANA 51 schema or HANA 50 schema, you can have the same customer table. That's why schema name dot table name is always a unique identification. So insert into this table values. So first we have is customer ID, right? If I double click on the table, what are the columns in this table? Customer ID. So customer ID, I'm giving it as 1001, comma, followed by customer name, address, phone number. Okay. So customer name, I'm giving it as Ram. Writing any string data, you always write it in single quotes. Integer data can be written directly. Integers or decimals, please write them directly, no problem. But if you're writing a char data, string data, always keep it in single quotes. Okay. So address, I say it as something like, I'm just taking some, not taking cities, taking some, because I'll create city again after using this. Okay, case statements. So I'm just giving something, and phone number I give it as 9814, something like that. And your statement with a semicolon. So if you execute this statement, if you want to write multiple records, you can say simply Control C, copy this, Control V. I'm writing 5 records. Change the data in this 1002. Once again, same name. Let's say. So now I select 5, all the 5, and say execute. Okay, so now it will execute all the 5 statements. So here you can see whether all 5 are successful or not. Yes, all the 5 statements are successful. Okay, if there is any error, you get a red mark here in the statements. So now we created a table and we written 5 records into this table. If you want to see the data in the table, so right click on your table. There is a concept of open content in the table. Open definition will show you the structure of table. Open content, you see the data present in the table. So now in this customer table, we got some 5 data records. Okay, so we created a customer table. We'll return some data into this table. Okay, so now if you go to the table, so refresh once, please. Always make sure when you make any operation, please refresh in HANA. Now we go to the runtime information. So there you can see number of entries we have in the table is 5. Okay, and total size of this table is 70 KB. Out of 70 KB, so 69 KB is from Delta storage, only 1 KB in the main storage. Means I can say all the 5 data records, whatever you loaded into this table, that entire data is present in the Delta storage location. Okay, is it clear? So is it making sense now? So whenever we write the data into columns to a table, we always write the data into a Delta storage location, which happens to be a row store. Okay, so that's the reason why write operation is quick in a table. Okay, and there is a concept of delta merge, which will migrate or which will move the data from a delta storage location to main storage location. Right? Maybe if you wait for 3 to 6 hours, it will be done because this delta merge is an automated concept. Okay, you don't need to do it manually. If you wait for 3 hours or wait for 6 hours, it will be automatically done, guys. So no, not an issue. Okay, but generally, if you want the data to be immediately moved into main storage, you can do this delta merge manually also. There is a so generally we never do the manual merge. So it's always through the auto merge only. Okay, so if you want, okay, now I just want to show you immediately. So let's make a manual merge. Now right click on your customer table. So there is an option called last option. If you take a right click on your table and say pick the option perform delta merge, it will make a manual delta merge. Say okay. Right click on the table. This is the option perform delta merge. Say okay. Now refresh your table. Now the overall size is only 49 KB. So 33 KB is in main storage and 16 KB is in delta storage. So don't think that the 16 KB in delta storage is some data is left over. It's a wrong assumption. It's a 16 KB is due to the structure of a table. Even your table has 4 columns, right? Customer ID, customer name, address, and phone number. Even this structure occupies some data. You agree with me? Even the structure occupies the data, please. Okay, and the size of the structure is 16 KB. Okay, so after merge, you see some size of a delta storage because if you have a table with 5 columns, customer ID, CU, ST, IDs, even that is also a data, even that needs some space. Okay, so the structure of your table also needs some space. Okay, so that space is 16 KB. So means after delta merge, there won't be any data left over in the delta storage location. All the data will be migrated into the main storage location only. Okay, but still you see some size of delta storage location because that is due to the structure. Okay, so after migration into the main storage, if you observe carefully, guys, after loading data into the main storage, if you carefully observe, okay, so the size has been reduced. Earlier it is 70 KB, now it is only 49 KB. Okay, out of 49 KB, 16 KB is went into the structure. Means only 33 KB is present in the main storage location. Even in that 33 KB, 16 KB is again structure again. I can say means now 70 KB data or almost some 50 KB data has been reduced to some 15 or 16 KB. There is like 3 times reduction in the database space. Guys, earlier it is 70 KB. 1 KB is in main storage location, 69 KB is in delta storage. Means I can say out of 69 KB, some 16 KB is for structure. So means 53 KB. So 5 records occupied 53 KB of data. After migration, if you observe carefully, okay, so these 5 records came to main storage, but it is now only 33 KB. Out of this 33 KB, some 15 to 16 KB has been your structure. Am I correct? So means your 53 kilobytes of data has become 18 kbn. Means there is a 3 times reduction in the database space. 3 times database space has been reduced 3 times. Okay, so by moving the data from delta storage location to the main storage location, anytime you migrate your data from a delta storage to a main storage location, okay, there will be a reduction in the database space. So we call this as compression. Okay, we call this concept as auto compression in SAP HANA. Call this concept as auto compression concept. Okay, so HANA in HANA database will be compressed automatically. Means you don't need to run any job. Okay, you don't need to run any particular program. So you don't need to do anything to compress the data in SAP HANA. In HANA, compression is done automatically. So here, so in HANA, I can say data compression is due to column storage. Okay, so in HANA, data compression is mainly due to column storage. Okay, This is the second advantage of column store, guys. The main first advantage is reading will be very quick. Okay, and second advantage is okay. The first advantage for a column store is reading operations will be quite quick, so which will be helpful in OLAP operations. And second advantage by storing data in column stories, you get an automated compression of data. Okay, so here it is 54 KB, almost 53 to 54 KB has been reduced to 18 KB, 3 times reduction. But if the data is in terabytes, guys, the reduction rate will be even higher. Means if you take 10 terabytes, okay, it will become 1.5 terabyte in HANA. It's almost like 6.5, 6.7 times reduction. Okay, so the data volume becomes higher, the reduction rate also grows up. Okay, so now what leads to the automated compression in a column store? Okay, so how do you get an automated compression in a column store then? So the next agenda is, so let's being a developer you should know, right? Okay, so how column store gives us an auto compression of data. Clear? Everyone clear so far? The table creation and data loading into the table and delta merge. Clear? Clear, sir. Right? So no one is responding.
Clear, Satya, clear.
Because I continuously for 20 minutes, I'm not sure how many. What is. So how the auto compression works? Just give me a minute.
Hello,
Yes.
sir. When
Okay, now let me show you how do we make an auto compression. See, I have a table. Okay, we got some index. So I have some country column, product column, and revenue. So for every HANA table, index is automatically created. Okay. So I have a table with 3 columns: country column, product, and revenue column, guys. So if it is a row store table, data will be stored in 10 storage locations, right? Every row data will be stored in single storage location. Super, well and fine. In the column store table, the same data will be stored in 3 storage locations. The entire country column data in 1 storage location. So the entire product column data in 1 storage location and revenue column data in 1 storage location. So how column store gives us auto compression is by storing only the unique values. HANA gives auto compression with the column store. So by storing only unique values. If you're storing the entire country column data at one place, so now if you see, though you have 10 records, the unique values are only 3. Okay, now you got 10 records. How many unique values you have? India, USA, Japan. That's it. The same 3 countries has been repeated for 10 times. Instead of storing the data for 10 times, it will store only 3 unique values. Same with product column data. Okay, if you see the data, product lost connection. Hello, can you hear me?
Yes, sir. Yes, sir.
Yes, sir.
So generally, how HANA gives you an automated compression in column stories by storing only unique values. Okay, so means country column, though it contains 10 records, so the storage happens only for 3 records: India, US, and Japan. And every table will have an automated index. It will have an automated index here. So and it will show you, okay, India, okay, in how many rows this India has been repeated. It is repeated in row number 1, row number 6, 8, 10, like that. So how many times it repeated, you can see the values, row numbers. So USA 347, Japan 3, okay, 359. So product, okay, so A, B, C, D, in how many rows this has been repeated, and then revenue. Okay, so the 5 unique records and how many times they have been repeated. So instead of storing the entire data, so being a column store, instead of storing the entire data set, it stores only the unique values. Okay. So automated compression in HANA is due to storing unique values. Okay, by storing only the unique values, okay, it gives us automated compression. Okay, that's the first thing. And generally, guys, this compression rate is very high in your mass data columns like product, okay, like customer, like company code, like an account, GL account. Okay, because if I take a company, my company has some 20 products and some 1 million transactions happen, okay, on 20 products. So means in all the 1 million transactions, the product details will be any of these 20, right? I say there is a product X, some 3 lakh transactions happen on product X, means in all the 3 lakh transactions, the product details are same. Okay, so the compression rate will be very high in your mass data columns like product, customer, because one customer can do multiple transactions. Okay, in our sales organization, a division, okay, or something like an account, a company code. So the data compression rates will be high on these columns. And when you take revenue, number of items sold, profit, date, here the number of transactions will not be heavy on this particular stuff, right? So the revenue generated will not be same for multiple transactions. So in these columns, in these types of columns, okay, the compression rate will be very low. You take transaction ID, guys. Every transaction will have a unique transaction ID. In these columns, the transaction compression rate is, frankly speaking, minimum. Okay, so you get a high compression rate, 99% compression rate in mass data columns, and you get low compression rate in some transaction data columns like transaction ID, okay, pricing, okay, profit, etc. So dates, calendar dates. So in these play scenarios where the data changes frequently, so the compression rate will not be so high. Okay, yeah, but on an average, I can say you get 3 to 6 times compression on the overall data set. Okay, so by storing the data in the column store. Yeah, guys, I guess now we got a clarity on delta merge, delta and main storage locations, and how the auto compression works under SAP HANA. So we created a table, okay. Uh, so we loaded data into the table and we made a delta merge on this table. So let me show you how to create a table. Okay, just want to speak something about primary key and everything. So let me create a table using SQL script. Okay, just a minute, please. Let me get some water. Just a minute. Okay. So guys, now let's try to create a database table using script. So one thing guys, in HANA database, the biggest advantage we have is every time to create something, you don't need to write a script, please. You can directly using the interface. You can right click and say take the option new table and do this stuff. Okay. Scripting is not required all the time, but this is like part of trainings. I'm doing the scripting to create a table, but frankly speaking, in real time, when if we create a table, we never go with the script. Scripting is minimized here. I can say that. Okay. So now I say let's create. Okay, I'm creating a table, so I just make it as a column store table. I'm creating a column store table and the schema Hana 52. And this table name I'm giving it as something like customer, or I make it as account table. I need two tables, so I'm just creating another table using script. Create a column store table, Hana 52 dot account. If you take row table, create row table, it will become a row store table. Hana 52 is your schema name, followed by account is your table name. Okay. Any name you always write it in double quotes. Okay, I'm just creating a column store table. So what columns I'll say I create in this account table is something like same customer ID. So that is integer data type. So mention the data type, comma. So next column I select is account column. So this is also an integer type I go with. Then I make something like bank. Bank is varchar. Max length 10. Then I go with balance. So balance, I'm just going with a decimal data type with length 10, comma 2. Okay, means maximum length is 10 digits. After decimal, it's 2 digits. So I'm creating a 4 tables. Okay, so then if you want any primary key, making a primary key, that is customer ID, making customer ID and account as a primary key. What happens if we select customer ID and account as a primary key? Okay, so if we select multiple primary keys, what is the concept of primary key? If we select customer ID as a primary key, so there is no two records that contain the same data, right? No two data records should contain the same data under customer. And if suppose you have one record with customer ID as 1001, you cannot have another data record with same data as under customer ID column. 1001 cannot be repeated now. It will throw out an error. If you select both customer ID and account as a primary keys, so data can be repetitive, means you can have two records with same data under customer ID column. You can have two records with same data under account column, but the combination should be unique always. Means I can have two records with same customer ID 1001. Okay, I can have two records with same account number. But suppose I have a first record as customer ID 1001, account number is 784621 something. I cannot have another record with same customer ID and same account number. That should not be done. Okay. So now I execute this table. So now your table is created successfully. Okay. So go to your tables part, right click. Let's say refresh your table now. So now we created an account table. If you double click on this account table or open definition of this account table, it will open account table whatever we created. So table name is account table. It is created in Hana 52 schema because create column store table Hana 52 dot account, right? And it is a column store table, so that's why you see it as column store here. So what are the four columns we created? Customer ID integer type, account integer type, bank varchar with 10, decimal, balance is decimal with 10 comma 2, and here you see customer ID and account both are acting as primary keys. Okay, so data should not be null, and you cannot have blank data under primary keys, and data should be unique. The combination should be unique always. Same now if you go to the Hello, can you hear me?
Yes, sir. Yes, sir. Yes,
I
Satish.
just lost. Today my internet was completely fluctuating. If I go to the runtime information of this table, same it is created with both delta and main storage locations. Okay, let's write some data. I'm inserting data into the account table. I write some account number. Bank is something like HDFC. So balance something like 912.45. Okay. It's quite slow today. It's hanging out. Please wait. Writing some file data records into this table.
Sir, actually, if you create a row table, it becomes a column, right?
How it will become row to column.
Sorry. Hello.
No, it won't become. Why would it become row table to column?
But delta merge, it will. You said delta merge, it will convert into column based.
So delta merge is concept of only a column store table. It's not a concept of row store table.
Okay.
So balance I'm leaving the same, it's okay. See here guys, if we see, so the customer ID 1001 has been repeated, okay, not 1000, 1002 has been repeated 2 times, 1001 has been repeated 2 times, and account number is repeated. Here if you see here, execute. So all the first 4 records passed, 5th record has an error. Okay, what is the error in the 5th record? Unique constraint violated, because I made customer ID and account as primary keys. Okay, second record and third record has same customer ID, but account number is different, so it's passed. Okay, the combination should be unique always. But first record and 5th record has same account numbers and same customer IDs. That's why there is an error. So what I do is I'll change this. Change the customer ID to something else. Now again pass the 5th record. Now this time it will be a success. So now if you go to the account table, right click. Let's go to the open content of your account table. There you can see some 5 records posted in the account table. So we created an account, 2 tables we created, customer table and account table. Okay. One without primary columns and the second one is with primary columns. Okay. And now if you go to your account table, refresh. So you have the entire data present in the delta storage location. If you want, you can make the merge again, manual merge. Right now, remember it is 110 KB. Let's perform the delta merge. Say okay. Refresh. So now it is only 62 KB. So this is how your delta merge works. Okay. And we created 2 tables today, and we wrote the data into this table. So I stop here for today. In the next class, what we do is we will start creating some database views on those tables, views, triggers, sequences. We'll create some objects on these tables. Okay. So thank you. Have a nice day. Thank you so much.
Okay, sir. Good night. Bye.